Okay, it's Friday, woohoo! And I'll be back Monday. So let's take a look at today's lesson, lesson 2.5. It has to do with graphing inequalities. Graphing inequalities, all right? So the thing about graphing inequalities is we're going to shade. I don't know if you guys remember doing this in algebra. We're going to shade entire regions. And the reason we're going to shade entire regions is because there's many points that might be greater than 2/3 x minus 1. So let's first treat this like a regular problem. We're going to graph y equals 2/3 x minus 1. That's just a line. We've learned that we're going to start our line at -1 on the y-axis, and then we'll apply the slope. 2/3, which is up 2 over 3, up 2 over 3. So we'll go up 2 over 3, up 2 over 3, down 2, back 3. So we get a line, and sometimes when we graph we do a dashed or a solid line, but because there's a little equal sign there, we need to make sure it's solid. If there was not a little equal sign there, we'd make the line dashed, like in example 2. Because the line, it's equal to the line and it's also greater than the line. So let's go ahead and make a nice solid line right there. And what we want to do now is we want y to be greater. We want all of the points greater than this line, because that says y is greater than or equal to. So there's a whole lot of points. I mean, this point right here is greater than it. This point here is greater than the line. This point here is greater than the line. This point here is greater than the line. But all these points down here are not. So there's a whole lot of lines, a whole lot of points. So what we do is we shade. And the reason we shade it because we certainly can't graph all of the points. By shading the entire region above the line, we're going to go ahead and get all of the points on the graph that make y greater than or equal to 2/3 x minus 1. Alright, that's not too bad. Example 2. So if I take a look at example 2, it's the same type of thing. So let's first just treat it like a line. Y equals -x plus 5. So alright, 1, 2, 3, 4, 5. There's 5. I have a slope of -2 over 1. So instead of going, I'm going to go down 2 over 1, rise or run, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. But I'm not going to make a solid line. This time, I want everything less than the line. I want everything less than the line, but I don't want it to be equal. So I make a dashed line. It's really important to make it dashed. Don't make it solid, because I don't want it to equal the line itself, but everything below it, less than it, okay? So if there were an equal sign right here, I'd make it solid, but since there's no little equal sign, it's going to be a dashed line, okay? Little equal sign on the bottom means it equals the line. No little equal sign means it doesn't equal the line. If it does not equal the line, it's a dashed line, okay? Now, what do? Well, we want everything below the line. So we've got, if you think about this line, if you want to get under it, let's say it's raining and you want to get under it, underneath the line would be all of this region. So again, all of these points within here are all going to satisfy that equation. So the only thing we can do with it is shade everything below. Okay, shade below the line, everything below the line is going to work. Okay, that's not too bad. Alright, example 3. I want to graph 3x plus 2y is greater than 12. So before I do anything on this one, what I need to do is solve for y. So it says y equals, well, or y is greater than, okay? I need to get it in slope-intercept form. So if I take my 3x plus my 2y is greater than 12, and let's solve for y. So first of all, let's bring over the 3x. So we'll go minus 3x, right? Because we need to isolate y. Get y by itself. So minus 3x, I'll have a 2y. It's going to be greater than -3x plus 12. Okay, don't add those. They're different. I like the x in front for my slope. Divide by 2. And I'll have a y is greater than a -3/2 x plus 6. Okay. That's easy to graph now. Start up at 6. 1, 2, 3, 4, 5, 6. Slope is negative 3 over 2. Remember, rise over run, so I'm going to go down 3 over 2, down 3 over 2. So I'm going to go down 1, 2, 3 over 1, 2, down 3 over 2, and make it a dashed line. Okay, it's got to be dashed line because there's no equal sign. So take my pin out, get a dashed line because it does not equal it, and it says y is greater than. So I'm thinking, okay, everything above the line. So everything above the line would be greater than that line. So I'm going to shade this entire region here. Okay. Not bad. Let's go on example 4. So in example 4, the only thing I've got to be careful on is eventually I will divide by a negative. If I want to divide by a negative, I'm going to turn the sign. Okay, you wait and see. I'm going to turn the sign because I will divide by a negative 4. So let's go ahead and write it down. I got 3x minus a 4y less than or equal to 12. Okay, again, let's solve. So I'll bring over the 3x. So I'll subtract my 3x minus my 3x. I'll have left over a negative 4y less than or equal to, and I'm not going to subtract those. You can't. That's an x, and that's not. I'm going to go negative 3x plus 12. I like the x first slope. Now, here's where I'm going to turn the sign. So if I divide by negative 4, what I have to be careful about is when I divide by a negative, I turn the sign. So see this less than or equal to? Now I'm going to turn it and make it greater than or equal to. So let's rewrite my equation. I'm going to have a y is greater than or equal to a positive 3/4 x, because a negative divided by a negative, positive 3/4 x minus 3. Okay, so we can graph this. Start at negative 3. 1, 2, 3 for my y-axis. And then I'm going to apply my slope, up 3 over 4, up 3 over 1, 2, 3, 4, up 3 over 4. And I'm going to make it a solid dash. We're going to make it solid. It has to be solid because of the equal sign. So I'm going to take our ruler, make it a solid line. I'm going to read it, and it says it is greater than or equal to, so I'm going to make sure that I shade above so that every single point that is greater than or equal to 3/4 x minus 3. Not too bad. Alright, let's turn the page over. We got a couple of problems left to go. Alright, now, example 5. Well, we've talked about this. There's no x, it's just y. So first of all, let's look at the line y equals 4, okay? And if it's just y equals 4, then what happens is the height of 4 will always exist. So this is going to be a horizontal line. But when I make this horizontal line, I'm going to make it be dashed. Dashed because there's no little equal sign. So if it's going to be a horizontal line on the y-axis of 4, I'm going to go up to 4. 1, 2, 3, 4. Okay, right there. It has to be a dashed line. Can't be a solid line, so I go straight across at y equals 4. But I'm going to make it a dashed line because it doesn't equal the line. It's actually going to be everything less than the line. So y is less than all of this. All of that. Okay. That wasn't so bad. Last but not least. So example 6 is kind of like Jeopardy. Here's the answer. What was the equation? Okay. So the equation, let's start with y. First of all, looks to me like it's a dashed line. Of course, I'm not much of an artist, but I think that's a dashed line. So, and it shades everything below. So I'm going to go with less than, because everything's shaded below, right? And it looks like it might go through, oh, it's difficult to tell, but 1, 2, 3. Looks like it's got a y-intercept of 3, okay? I'll show you again. Looks like this is the x-axis. 1, 2, 3. Didn't copy very well, but definitely plus 3 here because it has a y-intercept. And then down 1 over 2, down 1 over 2, down 1 over 2. I'm pretty sure it's down 1 over 2 if I read it carefully. Again, it's not a very good picture, but I think Pretty sure it looks like down 1 over 2, down over 2. So it's a down 1 over 2x plus 3. That has to be the equation to make this line and this shading. Okay, I'll be home Monday. Here's your homework. You can work on your balloons also, but this needs to be done. So have a great homecoming weekend.